Welcome to half-life decay. Some things can never go away, especially when you look at this in atoms. They end up just splitting forever and ever and ever. So how does half-life decay deal with real life? Well, say you're a professional athlete taking a performance-enhancing drug, the food coloring being the drug and the water being your body. Each time the drug enters your system, it never fully leaves. It splits itself in half over and over, but it will never reach zero. Even if you have the most minuscule amount in your body, it is never fully gone. Now it's time for the half-life equation, which is simple enough. N is the end result of the half-life process. It will be whatever is left. N sub 0 is the initial amount. The half is always there and T always stands for time. The H stands for the half-life. Problem 1. The half-life of carbon-14 is 5,730 years. How much of a 10 milligram sample will be left after 2,865 years and after 4,500 years? When starting the problem, you should write down the half-life equation. N equals N sub 0 times 1/2 to the T over H. Then you should start plugging in your knowns. 10 times 1/2 to the 2,865 over 5,730. Then plug in your equation into your graphing calculator. The answer you should get is that N equals 7.1 milligrams. As you do the other half of the problem, plug in your knowns again. The only thing different is that it's 4,500 over 5,730. Then you will plug them into your calculator like before, and you should get the answer that N equals 5.8 milligrams. Problem 2. Radon has a half-life of 3.8 days. After 7.6 days, 6.5 grams remain. What was the mass of the original sample? Like the problems before, you should start by writing out the equation, then plugging in your knowns. You need to find the initial amount, therefore you have to divide 6.5 by 1/2 to the 7.6 over 3.8. Conveniently, that is 0.25, and when dividing that into 6.5, the answer will be 26 grams. And that's that. It's like the song stuck in your head, or the radiation at Chernobyl. Some things can never go away, so good luck and farewell, and I hope this video helped.